Hi, class. This is Mr. Kinzer, and this is our science time, our session. So if you would please turn to your notes, and today you should put 324 or 326 up in the top right corner. Go ahead and circle it. And today we're going to be looking at major ocean currents. Now, I know a lot of you are interested in oceanography, and I am too. As a matter of fact, when I was in Scouts many years ago, one of the merit badges that I worked on was oceanography, and I earned that merit badge. But I just remember being so interested in the oceans. They were such a large part of the earth, and I liked geography. I liked looking at a globe, and I had an atlas that my mother had gotten for me when I was probably about 8th grade. And so I looked at different maps and learned a lot about the rivers and mountain ranges, but I was always drawn to the oceans, and they were a place of mystery. And so the ocean has always mystified people. It has always been a wonder to many people, especially currents. When you think of these bodies of water that move through the seas, these currents that move in a steady direction, what an interesting thing, what an amazing thing to chart those things, and people have done that. So we're going to be talking about these ocean currents, and let's go ahead and define a current that is a good definition. So as a current in the ocean, this would be the waters of seas and of the oceans that are moving. You could say they are in a steady movement. So they're in a steady movement in one direction. You know, the scriptures teach of currents in Psalm 8. The psalmist says, O Lord, how majestic thy name is in all the earth, who has set thy heavens above. Let me see if I can read it here. I'm looking for it. Psalm 8. Who has set thy glory above the heavens. When I consider thy heavens, the work of thy fingers, the moon and the stars which thou hast ordained, what is man that thou art mindful of him, and the Son of Man that thou visitest him? For he has made him a little lower than the angel, and has crowned him with glory and honor. Thou hast made him, speaking of man, to have dominion over the works of thy hands. Thou hast put all things under his feet, all sheep and oxen, yea, and the beasts of the field, the fowl of the air, and the fish of the sea. And there we see in verse 8, and whatsoever passes through the paths of the seas. Those are the paths of the seas. Let's write that down. This would be a path. Paths of the seas. This is referring to those currents. This would be a path through the ocean. Verse 9, O Lord, our Lord, how excellent is thy name in all the earth. So long ago, sailors realized there were rivers in the oceans. You could say these paths are like rivers. They're moving water, rivers in the oceans. And what an interesting thing to be in a ship. I've never been on a ship out in an ocean, other than I was on a fishing boat in the Atlantic Ocean one time, but not very far, only about 25 miles off the coast. But out in the ocean, to be seeing your boat moving along in like this big river of water that's moving in one direction. Isn't that amazing? Well, one Christian whose name was Matthew Fontaine Maury wondered about these things, and he actually read Psalm 8, and he wrote about it later and said that he believed that there must be a way to chart these, let's see, I'm going to go back over, a way to chart, there we go, these rivers, these currents. And so he did much study, and he was the first. He became the first man to chart some of these worldwide currents. And we're going to be looking at these currents in a chart that will be providing you because he was the first to do this, and he was a Virginian. He lived in Virginia a little before the Civil War. He was doing this work, and he was called the Pathfinder of the Seas. He's a rather famous person because he was able to chart these paths. And of course, if a ship gets in these paths, these currents, it can lower its time crossing the ocean by several days even, because these currents are rather swift. For instance, the Gulf Stream current, they've measured the speed of the Gulf Stream, which is the current just off the eastern coast of the United States. This averages about 3 miles per hour. So this is a 3 mile an hour. It's like a fairly fast walk. The water's moving through the ocean in this river. Well, currents are primarily caused by winds that blow over the waters. So their cause is wind. So let's look at some factors now that affect the direction of the currents. The biggest factor, the number one factor, is the heat of the sun. So the heat beats down on the ocean. The sun warms the temperature of the water. So, of course, near the equator that has the greatest amount of direct sunlight, warm water will heat up there along the equator. And, of course, warm things rise. So it rises to the surface and then moves toward the poles. So there's a rising of the water that's moving and then a moving along the surface toward the poles. And then, secondly, you have cool water that sinks and flows along the ocean floor to the equator. So up near the poles, for instance, it's colder. The water is sinking. It's denser. The water molecules are not moving very fast. There's no heat or very little heat. So they're dense. They kind of sink. And, of course, as it sinks toward the bottom, it moves toward the equator, because what's happening at the equator? The water is moving up there, so there's an upwelling. And so we're going to show a little flow chart of that here in this next picture. Okay, so here's a little diagram. This line at the bottom is the floor of the ocean. This would be the abyss, and we see that E represents the equator, so that's the middle of the earth. At the far right you have one of the poles, say the North Pole. At the far left you have the South Pole, and so it's colder. The colder water is moving downward. It sinks, and then it moves along the floor of the ocean toward the equator. Why is it moving toward the equator? Why doesn't it just pile up? Well, it can't just pile up. It's got to spread out. The weight of water coming down on it will make it spread out, and so it moves, but it's moving to the equator because here at the equator, the water is moving upwards, and it's moving upwards because it's heated, and then it reaches a surface and it moves both to the north and to the south. So water moves upward because it's warming, it's becoming less dense, and it moves to either side. And then, of course, as it moves out to either side, toward the north or to the south, it's getting colder, right? As it goes closer and closer to the poles, and then it sinks, and then it moves. So you have what we call a convection cell. It sinks at the poles, moves along the floor, and it rises at the equator. Then it moves off, it gets cooler, it sinks, moves toward the equator, it gets warmer, rises. So we have this convection cell, and that's what they call these. These are convection cells. We see this, the same kind of movement, a convection current. Both of these would be convection cells. But we see the same kind of movement in the atmosphere. Same exact movement with the wind, because the air gets cooler at the poles, it sinks, and it warms up at the equator and rises. So we have the same thing happening there. Okay, so be thinking of convection. This convection will cause some of the currents. Also, a second effect or a factor that drives the direction of currents would be the Earth's rotation. So we have the rotation of the Earth. Of course, the Earth spins eastward about 1,600 kilometers per hour at the equator. So at the equator, the Earth is moving the fastest toward the east, and it's spinning every hour about 1,600 kilometers. Of course, after 24 hours, the Earth has spun all the way around. So what happens that water in the northern hemisphere moves clockwise, and water in the southern hemisphere moves counterclockwise. So let's give you a moment to write that down. So if you can just picture for a moment as we look at the Earth, and here's the equator that cuts the Earth. So this is the northern hemisphere. This is the southern hemisphere. And because the Earth is moving to the east at that speed, okay, the water from the poles and the water that's on the surface, your water, remember the surface water is moving away from the equator because it's warm water coming upward. So it's moving away. But because it's then being spun, okay, it's actually going to move this direction. And this water is going to move in this direction. Okay? So you see a motion there that is affecting the wind pattern. So, and the currents are also affected that way. Now, another thing is the actual wind patterns themselves. The wind patterns are influenced by this. So we have the wind pattern is determined by the spin of the Earth, And an example is that we have westerlies. We have westerly winds, and we also have trade winds. And of course, I've just shown you some of those that are determined by the spin of the Earth. So again, the Earth's spinning to the east, and as the water and as the air both move away from the equator, they are bent to the left, basically, and so they are developing a pattern there. So an example would be the westerlies and the easterlies. Now a third influence or factor on the currents would be actual continents. So we have these continents now that are, where the patterns of the currents hit a continent, and so a continent will deflect a ocean current. It will turn the ocean current by the shape of the continent. Okay, so each major ocean has a predominant current flowing within it. Okay, so continents. So for instance, if we have a current that's flowing, and as an example, let's say we have the continent of South America. Let's say we have the continent of South America down in this area, and of course Central America, and then North America. There's Florida, and there's Maine. Okay, so what happens when this current hits the side? This current hits the side of the continent. Well, it's deflected, and it will move this way. So it'll be deflected. And likewise, in the northern hemisphere, this current is moving this way, hits the continent, and it's deflected. And so here's where the Gulf Stream comes over and hits the coast of America, and it's deflected across. So we have this big current that kind of circles through the Atlantic in this direction. So you can see that's a clockwise current, and down here's your counterclockwise in the southern hemisphere. So the shape of continents will also affect these currents. Let's make a note that each major ocean has a predominant current. Flowing within it. So we see these great currents. Now what we're going to do is look at the worksheet, which I've given you, and I'd like you to turn, and we're going to go to part 2 of this ocean notes, and I'm going to give you some answers for that worksheet. So go to part 2 of the ocean notes, really the science notes. Thank you.